Okay, now this question we're being asked to discuss the differing stabilities of NF3 and Ni3. And when we read the question, we find that Ni3, a black-red solid, when it decomposes into its elements, which is a nitrogen gas and a solid iodine, whereas when we look at NF3, it is a colourless gas which doesn't react with water. So we've got differing reactivities here, and obviously we've been given some information to do with bond enthalpies here, which we haven't used in either part 1 and we won't use in part 3. So there's the expectation that we're going to do some kind of calculation here. Now obviously if we start with Ni3 and we decompose it, that's going to go into nitrogen gas as per the description, plus solid iodine, and that can actually, if we're talking about decomposing completely, means the iodine will keep on going until it becomes a gas, so we just break a few more bonds there. So we're really talking about the reactants minus the products with calculating using the bond enthalpies and or the bonds that get broken minusing the bonds that get formed. So we'll have a look at that calculation now. Now if we look at the equation of Ni3, going to half N2, 1.5 I2, remembering that this is a solid and that we would expect that to decompose further to a gas. That's a sublimation process there. We need to make sure we include that as well. So having changed that around a bit, obviously I've got to have 1.5 I2 molecules being sublimed from a solid to a gas. And now in this bottom line, all I'm really doing is replacing everything with numbers. That's 3 times the Ni value for that bond enthalpy, half of 945 for the triple bond with the nitrogen, 1.5 times 151 for the iodine bond, and then because we go from a solid to a gas, it's 1.5 times 62 for the sublimation enthalpy. And if we put that all together, we should have our answer, which is going to end up being and that equals negative 315 kilojoules per mole. So that's your final answer. Okay, now we also still have to calculate that obviously for NF3, and it's a similar process, except we don't have to worry too much about sublimation. It's a gas going to a gas. Now in this case, NF3 is going to be 3 times 278, that's the 3 bonds around the nitrogen. I'm going to be subtracting half of 945 for the double bond and 1.5 fluorines, and that should give us an answer of 123 kilojoules per mole. So it's for NF3. For Ni3, if you recall, we had negative 315 kilojoules per mole. So we can now make a direct comparison between those two. Obviously NF3 is endothermic because we've got a positive value, and Ni3 is exothermic because we have a negative value. And in an exothermic reaction we're much more likely to have a spontaneous reaction, and because the fact that we get this decomposition of Ni3, which is known for being a contact explosive anyway, but even if you didn't know that, the question tells you it tends to spontaneously decompose and react violently, that would tend to suggest that this has a very low activation energy. Okay, and that tells you a lot about its stability. And that's part 2.